everyone, myself Neha Shah from LG Institute of Engineering and Technology from the Department of Electronics and Communication Engineering. Today I will explain you examples based on properties of Z transform from the subject of Signal and Systems from the fourth unit, which one is Z transform. In the last session I had covered the properties of Z transforms, right? Now today we will be solving some example based on this. So the first example is find the Z transform of first x of n equals to n into a raised to n u of n. So if you want to solve this example by using the properties of Z transform, so starting with the solving this example as x of n equals to n into a raised to n u of n. As you know, the Z transform of some standard signal like a raised to n u of n, its Z transform is z upon z minus a. For that, the ROC is mod z greater than mod a, right? So you can see that this one is a raised to n u of n, and in the given example, you have to find out Z transform for n into a raised to n u of n. So for that, we have to just multiply this term with n, right? So n into a raised to n u of n. So to find out its Z transform, we will using the differentiation property. What is the differentiation property? If we will multiplying x of n means input signal with n, then its Z transform will be minus z d by dz x of z. It means differentiation in the z domain, right? So we will apply this property over here. So if we want to find out Z transform of n into a raised to n u of n, so its value will be minus z as it is, d by dz will be as it is, and what is the value of x of z? X of z equals to z upon z minus a. So over here we will apply z upon z minus a. Now if I am doing the differentiation of this term, so it will gives you the term as minus z will be as it is, the denominator will be as it is like z minus a. The numerator's differentiation will be 1 minus numerator will be as it is, and then we'll doing the differentiation of the denominator, it will be 1 divided by denominator whole square, means z minus a whole square. Now if I am simplifying this term, you can see that z minus a minus z into 1 means z. So z will be cancelled out and this term will be converted in the form of minus a into minus z. It means az upon z minus a whole square. So the final value of x of z equals to az upon z minus a whole square. And ROC of it equals to mod z is greater than mod a, because if we are doing the differentiation, then there will be no change in the ROC of the previous one. Right? So the final ROC is mod z is greater than mod a. So if we draw in the ROC in the z plane, you can see that on the horizontal axis it will be real part of z, on the vertical axis it will be imaginary part of z. Now if we are taking one circle with a radius of a, so the ROC will be mod z greater than mod a. So it will be the exterior part of the circle with the radius a. Now the next example is determine the Z transform of the following sequences. Sketch the pole 0 plot and indicate the ROC. Indicate whether or not Fourier transform of the sequence exists. The first term is del of n plus 5 and the second term you are given is 1 by 4 raised to n u of 3 minus n. Okay. So starting with the solving this example. So the first term is del of n plus 5. What is the equation of bilateral Z transform? X of z equals to summation n equals to minus infinite to infinite x of n z is to minus n. Right? Now, in the first term you are given del of n plus 5. It means the value of x of n equals to del of n plus 5. So instead of this x of n, we are putting del of n plus 5. So the term will be summation n equals to minus infinite to infinite del of n plus 5 z is to minus n. Now if we are simplifying this, as you know that the value of del of n equals to 1 for n equals to 0. So using the time shifting property del of n plus 5, so this signal will shift it toward minus 5 side, right? So on the minus 5 term, n equals to minus 5, its value will be 1. So this summation will change. For that, only the value of n equals to minus 5 will exist and the value of del of n plus 5 equals to 1 for n equals to minus 5. So we'll apply this rule over here. So the value of x of z equals to 1 into z raised to minus 5 because the value of del of n plus 5 equals to 1. So instead of it we have put 1 and the value of n equals to minus 5. So instead of n we have put minus 5. And as there is only one term, so we'll removing the summation. Okay. So this one is the final term. Now if we simplify this, you can see that z raised to minus 5 means z raised to 5 and 1 into z raised to 5. So the final answer is z raised to 5. So this is the final answer of x of z means z transform of the given sequence. Now if we're finding the ROC for this, you can see that if we're putting the value of z equals to infinite, then the value of x of z equals to infinite. So we'll not including this part, except this part all the term will consider as its ROC. So what will be the ROC? ROC is entire z plane except z equals to infinite because we'll not including z equals to infinite. Why? Because on z equals to infinite, the value of x of z equals to infinite, right? So we'll removing this part only. So after removing z equals to infinite, the term will be ROC is entire z plane except z equals to infinite. Now if we'll drawing the ROC, you can see that this one is the ROC. For that we'll drawing the z plane. On the x-axis we will taking real part of z. On the y-axis we will taking imaginary part of z. So this one is entire z plane, but except z equals to infinite, it will consider as the ROC. Now if we're finding the pole 0 plot, so you can see that only the numerator will be there. So there will be only zeros, right? And z raised to 5 means there will be 5 zeros on z equals to 0. So we can say that 5 repeated zeros on z equals to 0. So we have drawn on z equals to 0 by a circle. So it will representing as zeros. Okay. So you can see that the ROC include the unit circle. So the Fourier transform will exist. If ROC will not include the unit circle, then Fourier transform will not exist. But you can see that in this example, the ROC include the unit circle. In this ROC region, we can draw the unit circle, right? So in the ROC, the unit circle is included, so it will gives you the Fourier transform for this particular example. Now the next example is 1 by 4 raised to n u of 3 minus n. So we'll applying the properties. So starting with u of n. Z transform of u of n is z upon z minus 1 mod z greater than 1. This equation I have written from the standard signal Z transform, right? Now we'll applying the property time reversal to find out u of minus n. So if I am applying time reversal property, so the term will be u of minus n, and as you know that in the time reversal property, instead of z we have to convert it in the form of z raised to minus 1. So instead of z we will taking z raised to minus 1. So the term will be like this, z raised to minus 1 upon z raised to minus 1 minus 1. And the value of ROC will be z raised to minus 1 should be greater than 1. Now if we simplifying this, then the term will be 1 upon 1 minus z. And this term will consider as 1 by z should be greater than 1. It means the value of mod z should be less than 1. Now the next term is we have to find u of minus n plus 3. Plus 3 means we have to shift the signal, right? So for that we have to apply the time shifting property. So using time shifting property, x of minus n plus k, its z transform will be equals to z raised to minus k, x of z raised to minus 1. So if we are applying this rule over here, so the next term will be u of 3 minus n. Its z transform will be z raised to minus 3, 1 upon 1 minus z. The value of mod z will be less than 1. In the shifting of the signal, there will be no change in the ROC. Now, if we simplify this term, it will give you the term as z raised to minus 3 upon 1 minus z. Now we have to find out 1 by 4 raised to n into u of minus n plus e, right? It's that transform. So for that we have to apply scaling property. Now if we'll applying the scaling property in the z domain, so the term will be like this: a raised to n x of n, the z transform of it equals to x of z by a. So instead of z, we have to take the term as z by a. So if we are taking like this 1 by 4 raised to n u of minus n plus 3. So you can compare this equation with the above equation. So you can see that the value of a equals to 1 by 4. Right. So instead of z, we will taking z upon 1 by 4 and each and every term. So the term will be like this: z upon 1 upon 4 raised to minus 3 into 1 upon 1 minus z upon 1 upon 4. And in the ROC also will taking z by a. So the value of a equals to 1 by 4. So the term will be z upon 1 by 4. This should be less than 1. Now if we simplifying this term, then the term will be like this: x of z equals to 4z raised to minus 3, 1 upon 1 minus 4z. And if we simplifying this, 1 by 4 goes over here. So the term will be more z should be less than 1 by 4. Or the final answer will be like this: x of z equals to 1 upon 64 z raised to 3, 1 upon 1 minus 4z. The value of mod z should be less than 1 by 4. Now from this we have to draw the ROC and pole 0 plot. So this is the final answer of Z transform. Now from this, first of all we will drawing the ROC. To draw the ROC, we will drawing on the x-axis we will drawing the real part, and on the y-axis we will taking the imaginary part of Z. Right. Now if we will taking the final ROC is mod Z should be less than 1 by 4. So we will drawing one circle with a radius of 1 by 4. And if we are taking the final ROC, mod z is less than this, it means it will be the inner part of this circle. So if we are drawing the final ROC will be the inner part of 1 by 4 circle. So the unit circle is with a radius of 1, right? So it will be greater than 1 by 4. So it will be outside of this 1 by 4 circle, right? So this one is the unit circle with a radius of 1. Now from this graph you can see that the ROC does not including the unit circle. Unit circle is outside from the ROC. So from this we can say that Fourier transform for this particular sequence will not exist. Now if you want to draw the pole 0 plot, you can see that there will be not a single 0, but there will be some poles. First one is z cube. Z cube means on z equals to 0, there will be 3 repeated poles. And the second part is 1 minus 4z. So, fourth pole will be on the 1 by 4 term. Okay. So, these are the pole position. Now, ROC does not include the unit circle, so the Fourier transform does not exist. Now the next example is find the Z transform of the signal x of n equals to n into minus 1 by 2 raised to n u of n convert with 1 by 4 raised to minus n u of minus n. Now if you want to solve this example, we'll using the properties of the Z transform. So starting with this, solving this example, the first term we'll consider as x1 of n, the second term we'll consider as x2 of n. So x of n is basically considered as x1 of n convolved with x2 of n. So as you know that the property of convolution is x1 of n convolved with x2 of n. So its Z transform will be considered as x of z equals to x1 of z into x2 of z. So for that we have to find out x1 of z and x2 of z. So for that, first of all we will letting the first term as x1 of n equals to n into minus 1 by 2 raised to n u of n, and this second term we will consider as x2 of n. Now we have to find the z transform of this particular term. So first term we will consider as a raised to n u of n. So as you know that the standard signal z transform like a raised to n u of n, so its value will be z upon z minus a, and ROC for that equals to mod z is greater than mod a, right? Now, if we are comparing this term with this term, so you can see that a raised to n u of n means the value of a equals to minus 1 by 2. So the final answer of the Z transform of minus 1 by 2 raised to n u of n is Z upon Z minus A. Instead of A, we have taken minus 1 by 2. So the ROC will be more Z is greater than more A. A equals to minus 1 by 2. So this one is the final term. Now we have to use the differentiation property because we have to find the Z transform of n into minus 1 by 2 raised to n u of n, right? So we'll applying the differentiation property as n into x of n, its Z transform will be minus Z d by dz x of z. So what will be the Z transform of it? N into minus 1 by 2 raised to n u of n, its Z transform will be minus Z d by dz. Instead of this x of z, we will apply this term. So the term will be Z upon Z plus 1 by 2. The ROC will remain as it is. Now if we will finding the differentiation of this, the denominator will be as it is and numerator's differentiation will be 1 minus the numerator will be as it is, the denominator's differentiation will be 1 divided by denominator whole square. Now if I am simplifying this term, so the final answer is x1 of z equals to minus z by 2 divided by z plus 1 by 2 whole square. And the ROC will be more z greater than 1 by 2. Now we'll taking the second term as x2 of n equals to 1 by 4 raised to minus n u of minus n. So starting with the sequence u of n, its Z transform will be z upon z minus 1. The ROC will be more z is greater than 1. Now we have to find out u of minus n's Z transform, right? So we'll applying time reversal property as u of minus n. Instead of z, we will applying z inverse. So the term will be z inverse upon z inverse minus 1. Instead of z, we will taking z inverse greater than 1. Now if I am simplifying this, the final term will be 1 upon 1 minus z. More z should be less than 1. Now the next term is 1 by 4 raised to minus n. So using scaling property in the z domain, a raised to n x of n, its z transform will be x of z by a. Now you can see that 1 by 4 raised to minus n, it will convert in the form of 4 raised to minus 1 raised to minus n. So 4 raised to minus n minus 1 means 4 raised to n u of minus n, right? So the value of a equals to 4. So after comparison of that, you can see that 1 by 4 raised to minus n u of minus n, its z transform will be 1 upon 1 minus z by 4 and ROC will be z upon a. The value of a equals to 4. So z upon 4, this should be less than 1. Now if I am simplifying this term, so the final answer is 4 upon 4 minus z, and after simplification of this, the final ROC is more z less than 4 because 4 goes over here. Now this one is the z transform of the second sequence. Now we will applying the convolution property of the z transform. So this one is the x1 of z, this one is x2 of z. If I am applying convolution property, so the final value of x of z equals to x1 of z into x2 of z. So just we have to multiply these two terms. So the final term will be like this: 2z upon z minus 4, z plus 1 by 2 whole square. And what will be the ROC? ROC will be the combination of these two. The final ROC is more z greater than 1 by 2, but it will be less than 4. So more z is less than 4, but it will be greater than 1 by 2. So the combined ROC will be in between 1 by 2 to 4. So if we are drawing the final ROC, you can see that this one is the z plane. In this, on the x-axis we have drawn the real part, and on the y-axis we have drawn the imaginary part of z. Now first circle we are drawing with a radius of 1 by 2, and the second circle with a radius of 4. So it will be outer side of this 1 by 2 circle. Now the combined ROC is in between this two circles, so it will be ring in between these two. So this one is the final ROC. So this way we can solve any example of the Z transform by using different properties of the Z transform, and from that we can draw the final ROC as well as pole zero plot, and from that we can also find whether the given signal Fourier transform exists or not. Thank you so much.